Okay, the bracket number changes it horizontally. So you could move left or right. What kind of number do I have to see to move left? A positive. Hey, that makes my brain think opposite brain mode, right? And subtracting a number actually moves it right. And then the detached number moves it up or down. Okay, but that's the same brain mode.
So what does the bracket number do again?
Left or right, horizontally shifts it. Like this, we'll move somewhere that way, right? Okay, so in other words, here's what happened. The vertex, so this 0, 0, could change to left or right, so H, K, but we decided we would take opposite value, same value. Day 2. The second thing we did. Okay, so this is on your formula sheet. This is on your formula sheet. Okay, tell me what's different about those two equations. They're both on your formula sheet, and?
The detached is on
The detached number moved here. So, now tell me your vertex. How did I do the vertex here versus how would I change my idea here? That's all I'm changing. I'm taking those same numbers, the bracket number, the detached number, there's only one thing that's different. This is the same, I didn't do anything different, but now this one has to be opposite because it moved onto the opposite side. Okay? Guess what? It tells you in the formula. Look at my formula sheet. If it says negative h inside the formula, doesn't that negative mean to do something opposite? And if it says plus k, what does that say? Do the same. What does this formula in the formula sheet say? Negative. So do it opposite. Okay, it's very straightforward if you just think about the formula. Okay, you're going to kind of quiz yourself here. Transformations. Give me 2 answers in words. So we had our normal thing. How does it change? You get 30 seconds to answer each question, and then I'm going to grade you. 2 answers.
The vertex is going to be down, like 1 down.
Okay, I'm looking for, ready? I'm looking for the word narrow and down 1. Can you visualize just a simple picture? There's your simple thinking of what it would do. The vertex is down a little bit, and it's narrower. Here's why. You know how my arms normally move 1 and then 1? Think about multiplying that by 4. You would move 1, but you'd have to go 4 up instead of 1 up. You'd have to multiply it, right? Okay, B. I need you to give me 2 answers for B. 2 answers. And give yourself check marks if you got flip and if you got left 4. Okay, check or X. If you got an X, write down X, and then correct yourself on your paper. So when you look back, you know what happened. Super quick visual.
Do you always want us to have that visual?
Nope, I'm just like making people reinforce this in their brain. How does that look? Is the vertex moved over, left, and upside down? Okay, the arms are technically that same arm pattern, it just literally went upside down. Question C has 2 answers. Okay, 100% if you wrote wider and right 2. Wider and right 2. Okay, I just want to reinforce something here. You know how over and up, 1, 1, 2, 4, 3, 9. Got it? That's normal. But we have a multiplier, so you know what we do? We have to multiply, because BEDMAS says to square something and then multiply it. So that's what I did. This is kind of squaring and then multiplying. So does this make sense why it's wider? Over 1, up a half. If you go over 2, you're only going up by, how much does this make? 2. Okay, so you see why it goes to the out more. Okay, versus this, if you go over 1 and then up 4, that makes it skinnier, right? You see the difference. Okay, last one. You need 3 answers. You need to provide 3 answers. Bless you. So, check marks. Did you write flip, narrow, and up? 5. Got it? So, do you see how this number is -3? It's a single multiplier, but you got to talk about 2 things. Okay? That's a general idea of what it would do. Okay. Next. Okay, so this was a formula sheet thing. And what did we say about the vertex bracket number, detached number thing? What did we indicate to our brains here? That it's opposite and opposite. Versus, what does this kind of look like as a formula? Where's the detached number on this one? You see it? My detached number was on this side, now it's on this side. So what did we talk about the vertex here? HK, bracket number, detached number, but what was the brain situation there? Opposite and same. All right, ready? Tell me, vertex, vertex, go. Each one. I want you to write the vertex and the vertex of each one. Bracket number, detached number, always. But think, what am I doing? Opposites, same, I don't know. All right, check marks. Ready? -3, -4, check mark. Did you get it? +1, +8. Check mark. Do it again. Okay, next, slope. Okay, it's the multiplier. So write down the next thing. What's the slope value, the multiplier value, the change of our pattern? Did you tell me? 2 and -1. Give yourself check marks if you're getting these right. Okay, direction. So if you're multiplying by 2, your direction. What do you got? You got U's that go up or downward. So you got to write direction. So I'm either looking for up or downward. So give me 2 answers. And there's your answers. Upward. You can either write or draw a picture or both. I don't care as long as you're telling me something about it. Okay. Axis of symmetry is if I could cut them in half symmetrically, right? Symmetric half. What kind of line did I draw here? Vertical. How do you write a vertical line? I've done these so many times already.
Hey, it's class time. It's fun.
Yeah, he's not consumers. He's a dog.
Okay, what'd you get? How'd you create me a vertical line? X equals. Okay, this is the #1 mistake on the test. People forget to physically write X equals. Okay, what X value? What's my X value? I travel through. Where do I find that X value? Vertex. You have to go through the vertex, right? So what are you picking as a number? -3, 1. Okay, so why do I get this mistake? I get people who write -3. Okay, great, you got the number, but you didn't make a line. Okay, domain. Are you going to get this point for free?
Yeah.
Okay, talk to me about the left to the right of it. How much does any parabola go left and right? Okay, unless it's a word problem, then there's some kind of material attached to it, but yeah.
Do we get all the word problems in this?
We will at the end, yeah. Okay, here's the only time I've kind of seen a mistake on this. That person got it wrong. That's a mistake. So they got theirs wrong. Why? Why did I give them an error? What do you think their mistake is? It's reversed. Domain has to go left to right, and they wrote right to left. Okay? Other words, it's like reading a book backwards. You're not going to do that. Range. What does range depend on? Direction. What does direction depend on? Slope. So this is already what we know. We said that one should open up, and we said that one should open down. So that's a line on our range. And you have to write it how? Low to high. Low to high. Okay, so they're going to be different. They're going to be different. Did you get it correct? Low height, where do I find heights? Y values are heights. Up or down, detached up or down is the height to up. Okay? Did you write it in that order? Low, high? Did you write a square bracket? Got it? Those are all deductions. What is this one? Low, high? Okay. Our next is, hey, what's a y-intercept? So we just have a general definition. When you're a y-intercept, you're on the y-axis somewhere. You have to be on this. And what's the criteria to be on this? X is 0. Guess what I'm doing? Plug in. If I know X, X is an input. If you know input, you can get output. That's what that is. If you know input, figure out the output. That's a plug in. Okay, please think about bed mass. Get your bracket number, square it, times it, add or subtract. Bed mass. So that is 9.
Oh. Oh, yeah, that, yes. No, I did mine. I did mine. No. I did mine.
So it was a plus 3 of that.
No, I did mine. That's
That was 4.
Okay, all by yourself, get the second one too. Get the other one, same thing, right? Plug, get an output. Plug in, input, output.
No, I didn't. I have all of them. You can read my work if you like. Should be put up in the museum. You don't.
Okay, I would say this type of equation causes the most errors. People get confused about that negative. So do you understand what I did here? I thought about the square of this, and then I did the times by negative after. Okay? All right, graphing. Here we go. Okay, here's your step 1. I did it to both. Step 1, draw a vertex. Step 1, draw the vertex. Step 2, arm pattern. So I'm always starting over, up. 1, 1, 2, 4, 3, 9. Over, up. 1, 1, 2, 4, 3, 9. Okay? There's the pattern that we started with. We're not going to do that because we just started with that. So what's the bed mass? So that's the square. What do we have to do after we square? Multiply. Multiply. Did we have anything to multiply by? 2. Okay, so I'm going to multiply this by 2. What about the other one? Did we have anything to multiply by on that one? Negative 1. Okay, so how does it look? We go over 1, up 2. What's important is resetting, right? You have to do a reset, so that means go back to the vertex. Are you heading up 8 to the next set? Over 1 up 2, over 2 up 8. And I can be done because my criteria is 5 points. That's my criteria. Okay? Hey, how does 14 look on the y-axis? Will we travel through it? Does it look appropriate? Yeah, looks good. Okay, I'm going to head up there. Good? And here's my vertex. And we talked about the arm pattern multiplier. So what does this look like? Over 1, down 1. Okay, you can see the flip, normal arms but flipped. This one is more narrow. Okay, this is the one thing that we talked about also yesterday that I didn't see on this. Okay, so they do look different in that way. One looks upward, one looks downward. Okay, this is a vertex, this is a vertex. But I did give them a special name also. Does anybody know the difference between those vertices? If I could give them a little bit of a special name, how they are located. Minimum on that one. Maximum on that one. Did you know that that corresponds to your range? What's the number on? The low part. What's the number on? The high part, right? Min, max. All right, and we have 2 questions to go today, and then we're done. All right, so this is an equation on your formula sheet. That is something on a formula sheet. And that's on your formula sheet as well. Okay, so I'm going to give you those 2 things. Okay, I don't tell you plug in. I don't tell you that. I give you that and I give you that. Okay, I told you this yesterday. It's not about 1, 2, 3 order. It's about A answers how many x squareds do you see? So how many x squareds do we see here? In ours, how many x squareds do you have? 1. How many x's is B? 10. How many just numbers? 16. Okay? Because guess what? I might not write it in that perfect order. I might mix it up and throw you off, right? Trick you? Okay, so what am I doing? Negative 10 instead of positive 10, negative 10. Divide by 2 times 1. Gets me negative 5. Okay, so here's what I know. Here's what I know. My vertex is negative 5, comma. Got it? That's the x value. All right, now, hey, what do we do if we have x? Plug it in. Input, output. Okay, trying to mental math this. Let's go. Positive 25, subtract 50, so that's negative 25 plus 16, negative 9. And there it is. Can you draw it? Okay, put it on there. Negative 5, negative 9. Okay, this was the brain buster yesterday. What does it mean when I want to get it to an x-intercept? Y equals 0. All right, so you told me to put 0 in for y. Okay, you can't use normal math to get this. So normal math would be isolation. So you can't collect, divide, okay? Why can't I collect terms? Because you have two different terms, okay? X squared and x are different. If I told you to put linear footage and area footage together, could you do that? You can't put them together. They're different. Okay, so you can't do that. But we do have a technique, and it is the math F word. Factor. Okay, and it's a type. Simple trinomial. So x times x to FOIL for the x squared. It's foiling backwards, brain. What are we picking to multiply to 16? You got 3 options. 1 times 16, 2 times 8, or 4 times 4. Something has to make 10 out of that. 8 and 2. Talk about signs. Plus, plus. Does that make plus 16? Plus 10. What x value creates 0? Okay. Here's an answer I got on somebody's paper. I got this answer on somebody's paper, and I told them they were wrong. Why are they wrong? Do you know what this is?
That's a coordinate, not a...
That is a coordinate over here. Do you understand this is technically a coordinate like that? So that's wrong.
Now you have to do, you add those up and divide by the
Okay, put them on. Negative 8, negative 2. Are things looking good? Yeah, why? So let's confirm. Confirm. What do we know? This was at negative 8, and this was at negative 2. They are symmetric partners, because they're the same height. So they're partners. So what do I know about the cut line, the axis of symmetry? Where should it fall with symmetric partners? In the middle. Add them up. Negative 8 plus negative 2 is negative 10. Divide by 2 is? Negative 5. Does that negative 5 number? Go into the middle. Yes, it goes through our vertex.
He said he looked at
Okay, y-intercept. So x is 0. So what am I doing? Plugging in. Yeah, but this one's quick. Why is it quick? Nothing plus nothing plus 16 is 16. Okay, can you put that kind of on there? I know it's not like on the graph, but okay, give me that. Do you understand the actual coordinate? If you could give it a coordinate, what is it? 0, 16. Okay.
Hey, it's crazy, dude.
I said it.
Okay, so I'm going to give you a question that you haven't done before. I want you to problem solve. Ready? I want you to figure out the point that's symmetric to that one. So AKA, what's the coordinate over there? It's a partner, right? Everything has a symmetric partner, except vertex, obviously. I want you to figure out how to get to that coordinate.
Would be negative.
Nope.
This
Don't
is
tell
a
me.
hard unit. This is a really hard unit. It is. I think we should all pay attention.
What are you pointing to?
Oh, I think you're exactly right.
Oh, yeah, I know.
This is a really hard unit. We have a test on this.
How's our problem solving? We getting there? Okay, guess what? I know. Boom. I know that. Is that your first instinct? 16 on the height. Okay. Who can get me a strategy? Who had thought of something?
Would just be like the next point, so it would just be over 3.
Over 3? Not
No,
quite.
Over 3, sorry. Over 2.
We believe in you.
Almost there.
Okay, here. I'm here. Now I'm here. Okay, what did you move over? How much have you moved over?
Would it be negative 10? How did you say 2? Would it be negative 10?
This is negative 5 and this is 0. So how many over?
Negative 10, 16.
So you had 5 moves off the line. So what do you have to do? You have to move 5 moves. You have to move 5 that way then. So what am I at? I'm at negative 10. How does that sound as a strategy? You got to think about, you're always in the middle. So 0, negative 5, negative 10. Okay, so this was my strategy. This was the x value, this was the x value, and this time we were going that way instead of the middle, right? Okay, here's your last question. Okay, this one's fun. It's got some decimals in it, ready?
Oh, it's fun?
Yeah, got some decimals this time. Here I go. Positive 5. See, why am I doing positive 5? Opposite, negative 5, yep. 2, 2. 2 times A. Okay, so 5 divided by 4 is not perfect, so that, can you get me something? It's decimally. Good? 1.25. Okay. What am I doing? I'm doing that. That's called a plug-in, right? Input. Okay, my expectation would be you're running this into your calculator on this one, right? You should be able to just let it flow. Don't worry about anything. It should do bed math for you. Are you matching me? Okay, y-intercept, you got 2 seconds. What's the y-intercept in 2 seconds? 16. Slope, quick. 2. Domain, quick.
5.
Domain.
A infinity positive.
Infinity. Okay, range. Think about it.
It is
Which direction am I heading first?
up.
I'm up. So,
Negative infinity?
nope.
Oh,
The other one?
no, he did.
Yeah, I called it already.
Low. Low needs to be a number.
What do you mean for?
Positive infinity.
Yes.
Okay, I'm going to sketch this for you. Here's why. My applieds have to learn this, but they are taught like this. This is how I teach them. Ready? So they get a fancy calculator. I'm going to hit y equals. Okay, does that match? 2x squared subtract 5x plus 16. Good? Graph.
Whoa.
What does that look like?
That was sick.
Parabola. Okay, so there's the graph. Good? How does that look? Do you want to wait 10 seconds? Is that okay? If you have to go, you can go, but I thought you'd be amazed by this. Okay, here's the vertex. Can you tell me the special name? What's the special name of this one?
The bottom.
Minimum. Okay, here we go. My calculator will do everything we just did. I'm going to calculate.
Whoa.
What did I tell you? It's called minimum. Here's what my computer tells me. Move to the left of that. Okay, good. I'm left. Enter. Move to the right of it. Enter. 185 bucks.
What the frick?
Look at, what's my coordinate? 1.25. 12.875. Okay. There it is, the minimum. No. There's my y-intercept. What was a y-intercept? Where x equals 0. So look at what I'm doing. 0. What was the y-intercept? 0, 16.